Hey guys, we are now on to lesson 3.2, complex numbers. So in this lesson, we are going to define the imaginary unit I. Yes, I said imaginary, not to be confused with imaginary friends. And we are going to use it to rewrite the square root of a negative number. We're going to learn to add, subtract, multiply, and divide complex numbers. And we are going to find complex solutions of quadratic equations and complex zeros of quadratic functions. So this part here is kind of like the last lesson that we did with the x-intercepts. It's just when we don't have x-intercepts, how do we handle it kind of thing. So let's start off with the definition of an imaginary unit. It is basically telling us that I is equivalent to the square root of -1. We also need to note that I squared is equal to -1. All right, so we're going to dive right into it. So we can break apart any negative square root by pulling out the -1, which becomes I. So for example, we can break this up as -1 times 25. So we got the square root of -1 times the square root of 25. Well, the square root of -1 is I, and the square root of 25 is 5. So we can rewrite this as 5 times I, or 5i. Now, I do want you to note, if you pull out an I and you still have something in the square root, the I comes to the front. Do not put it behind. It will get marked wrong because it's incorrect. So you need to move the I to the front. So we're going to look at an example of that in just a second. So B, we are going to factor out our -1, and then 72 is not a perfect square. So I need a factor of 72 that is a perfect square. So I have 36 times 2. And so I can find the square root of 36. So I got the square root of -1 is I, square root of 36 is 6, and then I have the square root of 2. So we can rewrite this as 6i square root of 2. So notice my I is to the front. So the square rooting part is not different than what we've done before. The only difference is incorporating that I. So C, we have that -5 in front. That -5 is going to stay in front. All right, so we're going to have -5 times. We're going to break up our square root of -1 into square root, or -9 into square root of -1 times the square root of 9. We can find the square root of 9. So now we have -5 times I times 3. So -5 times I times 3. Treat it just like you would any other variable, and we have -15i. All right, so hopefully you don't find that too difficult. How this is going to affect us in the future is whenever we get negative square roots, we're no longer going to say no solution. We're going to use the letter I. All right, so this next part, a complex number written in standard form, is a plus bi. So that's how we're going to make sure all of our answers in the future are written. This probably should have been down with the operations, but it'll be okay. We'll come back to that in a second. So two complex numbers, a plus bi. Well, I guess it explains this part, but we'll use this part more down here. All right, I'm done. Okay, so two complex numbers, a plus bi and c plus di, are equal if and only if a equals c and b equals d. So I highlighted those on my paper. They probably show up a little gray on yours, but just wanted you to know that we're looking at the real parts. We're going to set those equal to each other, and the imaginary parts, we're going to set those equal to each other. So what do I mean? Well, if I look at this, I have a 2x and I have a 10. Those are my real parts. There's no I value with them. So I'm going to do 2x equals 10. All right, and then I have -7i and yi, and those are my imaginary parts because they have I. So I'm going to do -i, -7i equals yi. And now I'm just going to solve for x on this one, y on this one. So how do we normally solve for x? We divide both sides by 2. So we divide by 2, and we get x equals 5. And that's it. That's all you have to do for that part. So here we want y by itself. So how do we get rid of I? Same way you would anything else that's being multiplied. You divide by I. So these i's cancel out, but these i's also cancel out. So we are left with negative 7 equals y. And those are our answers. So if you would like to try that with B, go ahead, give that a try. Pause the screen and see what you come up with. All right, so again, we are setting our real parts equal to each other. So 5x equal to 20. And then our imaginary parts, 4i and 2yi. And then we're just solving for those variables. So we would divide this side by 5, just as usual, and we get x equals 4. And then this time we have a 2 and an I with the y. We can divide by both of those at the same time. So those i's would cross out, that would become 1. We divide over here by 2i, the i's cross out, we got 4 divided by 2, which is 2. So we'd say 2 equals y. And that's literally all there is to those types. Okay. So now we're going to go, you're going to find the adding and subtracting pretty easy as well. Your answers should be in that standard form, the a plus bi. So your imaginary term should be second. Okay. So adding is just like combining like terms. So any other polynomial we've ever added together, we simply go through and add the like terms together. So in this case, what are our like terms? We have an 8 and a 5. Sorry that this is showing up so dark. I tried to find a different color highlighter, but... And a negative I and a 4. Well, I guess it's just because of the ink from the paper. So sorry that looks trashy. I guess I'll do something different. All right, so we got 8 plus 5. I'm just going to put it like here since we can't, I don't feel like they're showing up very good on the screen. And then our imaginary parts are negative I and 4i. Right? Yes, okay. I just wanted to make sure since they kind of blurred a little. That is an I. All right, so we just add them together just like you would anything else. 8 plus 5 gives you 13. Negative I, think about it as negative 1i, right? If there's none, there's 1. So negative 1 plus 4 would give you positive 3i, and that's your answer. All right. However, with the subtraction ones, you have to rewrite them. I find it easiest to rewrite them as an addition problem because you got to think about that negative has to go to both terms. And what happens is we'll typically put the negative with the first one, and then a lot of times students forget to do the second one. So I find it easiest to rewrite this as an addition problem. So remember, this just means everything inside the parentheses behind it becomes the opposite. So the 3 was positive, now it's negative. The 6i was negative, now it's positive. And so now we can combine our like terms. So we have our 7 and our negative 3, we can combine those together. Maybe this circling them would be better than highlighting them. And then we have negative 6i and positive 6i, and we combine those together. So 7 minus 3 gives us 4. Negative 6i plus 6i gives us 0, which equals 4. And yes, it is okay to not have an imaginary number in your answer. All right, so that's adding and subtracting in a nutshell. Those I think you guys will all do great with. We're going to move on to multiplication. All right, so multiplying, you can do the FOIL method. That's how I was taught. So there's a reminder. I'm going to do the box method because I've just found that students over the years typically do better with the box method. So that's what I'm going to use to multiply these. But these aren't even being oh my gosh. Sorry guys, I'll fix this on your copy. There wasn't supposed to be a sign here. Are these the same numbers? Yep, I accidentally put the wrong questions there. Hold on, I'm gonna get the right questions. Okay, voila, the problem is fixed. I will fix this on y'all's paper so y'all won't even see that by the time you get copies. Anyways, moving on. So we have, just like with distributed property, we're going to take that 4i, we're going to multiply it to -6. We're going to take 4i and we're going to multiply it to I. Could you do it in your head right now? Yes, but for note purposes, so you're not like, how did I get that? I'm going to just show you the work. All right, so essentially that's what we're doing. 4i times -6i, that gives us -24i. And then we have 4i times I, so 4i times I gives us 4i squared. Now, if you remember from the first page when I first introduced you to this, I squared is equivalent to -1. So you should never have I squared in your answer. So if you need to make a note of that over there, never put I squared in your answers. So what we're going to do is we're going to take this I squared. Gosh, I hate how it drags it. And we're going to turn it into -1. So we're going to bring down the rest of our problem. So now we have -24i plus 4 times -1. Well, what's 4 times -1? -4. So I'm going to move that to the front because remember, it's a plus bi is the form that it should be in. So I'm moving the real number to the front and I'm going to put the imaginary number in the back. And that is our answer for that one. All right, so now with this one, I'm going to do the box method. All right, I'm going to do it over here, I guess. I didn't leave myself a whole lot of room. So we got 9 minus 2i, and then we have -4 plus 7i. So you can do FOIL method again. FOIL method, you multiply that one to both terms, and then you got to multiply that one to both terms. Just the problem is that sometimes we lose numbers. So -4 times 9 gives us -36. -4 times -2i gives us positive 8i. 7i times 9 is going to give us 63i. And 7i times -2i is going to give us -14i. So I'm going to just rewrite this here. So we got 36, we have positive 8i, we have positive 63i, and we have -14i should be squared. Miss Gill totally forgot the square on that one. All right, so we're going to combine our like terms here, and we're also going to turn this into -1. So right here, they've got it right there too. I squared equals -1. So we got 36. We're combining those two together. So 8 plus 63 gives us what? 71. No wonder I make mistakes sometimes. I'm sitting here doing math in my head. All right, and then we got -14 times -1. So this becomes positive 14. And then now we can combine these two together. We're going to move the 14 up here so that way we have it written in standard form. So 36 plus 14, what is that, 50 plus 71i. I'm going to check my math just to make sure Miss Gill didn't have a moment. And Miss Gill totally had a moment. Hopefully y'all caught it. I'm sure Jacob caught it. If y'all don't know who Jacob is, Jacob's my corrector. All right, Miss Gill did not make our 36 negative. So -30, see, teachers make mistakes too. I make plenty of them, and I own them. All right, so we got -36 plus 14. That's what I get for not looking at my notes as I'm going through these. And that would equal -22. So we got -22 plus 71i. Now Miss Gill's answer is correct. If you're like, what kind of magic is Miss Gill making? Good for you. All right, I am going to stop this video here. I know it's not even 15 minutes, but this thing has been so ornery with me lately and getting to 20 minutes, and we still have 3 examples. So hopefully the next one should be less than 10 minutes, but I just don't want to push my luck. So I'm going to stop this video, make it a part 1, and we'll pick up example 5 through 7 in the part 2. So see you in the next video.